नहमदु व नुसल्ली अला रसूलिल करीम अम्मा बाद फ़ऊज़ु बिल्लाहि मिनश शैतानिर रजीम बिस्मिल्लाहिर रहमानिर रहीम Assalamu alaikum. My name is Engineer Farhan Tanveer and our today's topic is a very important topic for the CCNA 200-301 certification free online course. In today's topic we will be discussing the Internet Protocol version number 6. Our IPv6 tutorial will be of two parts and this video is about the part number 1, that is the basic concepts of IPv6 protocol, how the IPv6 addressing works and what are the different types of IPv6 addresses. So now moving to our presentation for today's lecture. So starting our IPv6 tutorial, and in this tutorial I will be telling you about the details of the Internet Protocol version number 6, and first of all we have to discuss the need for the IP version number 6 or the IPv6 protocol. As we know that the size of the internet is doubling every 9 months. In case of the IPv4 address, we have the 32-bit field. So with the help of a 32-bit field, we can have at a maximum of 2 to the power 32 addresses theoretically. But since we have different classes in IPv4 addresses, that is the class A, class B, and class C, class D and E. So the last two classes, that is the classes D and E, they are reserved and they are for multicast purpose and for reserved purpose, so they cannot be provided to the host. Also in the class A, B and C, there are several IP addresses which cannot be provided to the host PCs. So it means that we have a very limited resource in case of IP version number 4. But the 2 to the power 32 address bit field would have depleted a long time ago, but with the help of classless interdomain routing, that is CIDR, which I told you in my previous lectures, as well as the VLSM, that is the variable length subnet masking, and plus the use of public and private IP addresses using the network address translation router. So these three methods, that is the VLSM, CIDR and NET, these three methods helped us to basically extend the time period in which the IPv4 addresses get depleted. But eventually, the IPv4 addresses will be completely wiped out, and there will not be any other IPv4 address available for the new host coming into the internet world. So what should we do now? In the IPv6 protocol, that is the Internet Protocol version 6, we have the address bit field equal to 128 bits. So with the help of 128 bits, we can have 2 to the power 128 possible addresses that can be assigned to the host stations. So as we know that the Internet of Things concept, the IoT concept, will be effective in the fifth generation of mobile cellular technology, and therefore in that fifth generation, or the IoT concept requires a very large number of IP addresses. So that can only be achieved by the 128-bit field of the IPv6 addresses. So theoretically, in the IPv6 addresses, we can have 2 to the power 128 addresses available to us. But practically, there can be a reduced number for the IP addresses, but still in comparison with the IPv4, the IPv6 addresses are very large in number. So that was the prime motive for introducing IPv6, that is the avoiding the complete depletion of the IP addresses. But besides this prime motive, there are some other minor objectives also related to the IPv6. For example, the fragmentation concept in IPv4 is very harmful if we consider it with respect to the security point of view, because with the help of fragmentation, the hackers launched different types of attacks, and they designed different types of attacks like fragment offset overloading, etc. To avoid the fragmentation based attacks, the IPv6 protocol does not allow any type of fragmentation, unlike IPv4. So if you have created an internet data frame, which is internet data packet, which is larger in size as compared to the upcoming links maximum transmission unit, then the router will not be making fragments of your IP packet in case of IPv6, but it will return the source, the large developed IP packet, and it will ask the source that kindly divide this packet by yourself into smaller fragments. But in case of IPv4, if the MTU, that is the maximum transmission unit of the link, is smaller as compared to the size of the packet, then the router itself, without intimating the source host, uh, it itself divides the incoming packet into smaller chunks, or that is the fragments. So there is a particular raw in the IPv4 header that I have told you in my previous lectures, which is related to the fragmentation concept only. But in case of IPv6, there isn't any fragmentation concept. So this is the second difference between IPv4 and IPv6. First, the 128-bit address field, then the fragmentation concept. Third concept is that in IPv4, we had the broadcasting terminology. We had the unicast, multicast, and broadcast. But in case of IPv6, we don't have broadcast anymore. But instead of broadcast, there is any cast available to us. So what is meant by the any casting feature of IPv6? So basically, the any cast means that there are several nodes in the network available for uh, receiving the data. So if you give any of those nodes your desired data to be sent to a particular destination, then the destination will be getting your packets irrespective of which node is provided the data by you. It's just like the courier service. When you have a courier service, then there are different offices of that courier service in the city, and you give your parcel to any of the office, and that parcel will eventually reach its destination, despite of the fact that it was given, the parcel was handed over to the nearby courier service office, or courier service office someplace far away from your home. So this is basically that you have different nodes available in the network, and giving your data to any of the node will guarantee that your data will be sent to your particular destination. So that is called anycasting. While in unicasting, you have data destined for a single host, and in case of multicasting, you have a group of users to which you have to send your data. So this is another difference between the IPv4 and the IPv6. And the other difference, one another difference in case of IPv4 and IPv6 is that in IPv4, the ICMP protocol, the Internet Control Message Protocol, as you have already heard that the ICMP protocol, the Internet Control Message Protocol, is basically used for error detection or destination unreachable messages, or it is even used for pinging the devices. So the ICMP protocol was implemented as a separate protocol in case of IPv4, but in case of IPv6, the ICMP protocol is incorporated in the IPv6 header itself. So the IPv6 header can be extended, or it has an extensible IPv6 header. So the ICMP header can be incorporated in the IPv6 header itself as an extensible header. So you have not to implement the ICMP v6 protocol. ICMP v6 protocol is the ICMP version of IPv6. So the ICMP v6 protocol is not implemented as a separate protocol in case of IPv6. So that is another major difference between the IPv6 and the IPv4 protocol. And there isn't any IGMP protocol in case of IPv6. IGMP protocol was the Internet Group Message Protocol. So the IGMP protocol is not present in IPv6. Whereas in case of IPv4, the IGMP protocol was used by a host when it was going to become a member of a multicast group. Then by the help of IGMP messages, it informs the router that now I am a part of a particular multicast group. So any information which you send to that particular multicast group should also be sent to me. So the IGMP protocol task is now performed by the ICMP protocol, ICMP v6 protocol itself. So there are very large differences between the IPv4 and the IPv6 header formats. So these are the features of the IPv6. Most of these features are discussed with you. One more feature which I want to tell you about the security. And basically the security in IPv6 is very tight. In case of IPv4, we don't have the IPsec protocol as a mandatory feature. So IPsec protocol is the IP security protocol. In case of IPv4, whenever you create a VPN, that is the virtual private network, site-to-site VPN, then you have to implement the IPsec protocol. But for normal data transmission between the host, we don't have the need of the IPsec protocol in case of IPv4. But in case of IPv6, we have to use the IPsec protocol as a mandatory protocol. Another difference is the use of multiple addresses for a single host. As you have a very large IP addresses available to you, large range of IP addresses available to you in IPv6, so therefore you can assign a single host multiple addresses of different types that can be assigned to a particular host in case of IPv6. So this is a very large difference as compared to the IPv4 protocol. Secondly, one more feature is that you can create your IPv6 address by yourself. In case of IPv4 addresses, we have the auto creation of IPv4 address. That is the technology used as APIPA. This APIPA, that is the automatic private IP addressing scheme, that it is the own assignment of IPv4 address. So if in case of IPv4 address, you haven't statically assigned an IPv4 address, or you haven't assigned any DHCP server for the assignment of IPv4 addresses, then by using the APIPA range, which starts from 169.254, this range of IPv4 addresses can be assigned by PC to itself. So APIPA is the automatic private IP addressing scheme. But in case of the IPv6 address, you can ask the PC or you can ask the router to create its own IPv6 address using its own MAC address. So that is called the stateless address auto configuration. We will be discussing in our next few slides that how does a router or how does a node creates the IPv6 address by its own self using its MAC address. So that is another big difference between the IPv4 and IPv6 protocol. So moving further, this is the IP addressing of IPv6 protocol and the expression. As I have already told you that 128-bit address field is there, and this 128-bit address field is basically divided into two types or two portions, 64 bits and 64 bits. As you know that in case of IPv4 address, we have the network portion and the host portion. So here we don't have the network and the host portion. Rather, these are called as global prefix. The network portion is called the global prefix, and the host portion is called the interface ID. So these 64 bits are basically, this 64-bit is the network prefix, global prefix, or this is the interface ID. Plus the subnet mask is the built-in part of this global prefix portion. So here you can see that this 64-bit is divided into further 48 and 16 bits. These 16 bits are for the subnet, and these 48 bits are for the global prefix. And here the 64 bits are for the interface portion, interface ID. This is the host part of your IPv6 address. So another difference between the address field is that here you don't have the dotted decimal notation. The IPv4 addresses were called the DDN. DDN stands for dotted decimal notation, but the IPv6 addresses are basically the block hexadecimal block colon notation. Hexadecimal, why? Because 128 bit is a very large number, so you cannot use the decimal number ring system for expressing these 128-bit values. Rather, you use the hexadecimal pattern. So here you can see that this 56 AB is basically the hexadecimal portion. So these four hexadecimal digits are called a block. So as you can see that in this particular IPv6 address, we have 8 different blocks. First block, this is the second block, this is the third, fourth, and similarly 4 blocks for the interface ID portion, that is the host portion. So also you can see that the values inside the block are of 16 bits. So these 16 bits are represented by 4 hexadecimal digits. Uh, and one another thing is that these blocks are separated by not dots. These blocks are separated by simply columns. So you can see the difference between the addressing format of IPv4 and IPv6. And one more thing I want to clarify here is that how do we write the IPv4 address in the browser uh, bar. So here you can see that in the web browser, you usually type HTTP colon double forward slash and the IPv4 address is written. But in case of IPv6, you have a difference over here. You have to place this square bracket over here, and one is more square bracket is to be placed over here. So this is the way to write the IPv6 address. So this is a long format of IPv6 address, and in the next slide, I will be telling you how to shorten this large IPv6 address by using the shorthand expression. So now moving to the shorthand expression. This is the shortened expression, and this shortened expression is only helpful if you have consecutive zeros in your IPv6 address. Here you can see that this is an IPv6 address with these. There are 4 consecutive zeros in this block and 4 consecutive zeros in this block also. So what you have to do is to just summarize these 4 zeros in the format as a single zero. And similarly, these 4 zeros can also be summarized as a single zero over here. Similarly, the starting zeros can be omitted. So 0012 can be written as simply 12. And here you can see that 0db8 can be written as db8. Also, if you have continuous blocks of zeros, like here you can see that we have two continuous blocks of zeros, then these continuous blocks of zeros can be omitted completely, and a double colon can be placed in their place. So here you can see that these two zeros, these two blocks of complete zeros are removed, and a double colon is placed over their position. But that you can only do for one time. That is, you cannot have two double colons in your IPv6 address. So that I will be telling you in my next slide. So now moving to the next slide and explaining to you the uh, concept of these double columns. So consider this example. This is a very good example as we have now two consecutive blocks of zeros. Here you can see that this is two consecutive blocks of zeros, and these are also two consecutive blocks of zeros. So you cannot do this. That is, to place two double columns in an IPv6 address is not allowed. Now, why it is so? The reason behind this is that the router or the machine counts the non-zero blocks and then calculates the number of zeros blocks that will be present in the IPv6 address. So here you can see that we have a non-zero block of 2001, and then a non-zero block of 12, and then a non-zero block of 1234, and then a non-zero block of 56 AB. So there are 4 non-zero blocks. So the router or the other machine will get the idea that there will be 4 blocks of complete zeros present in this IPv6 address. But the machine will get confused if we place two double columns in this IPv6 address, because the 4 blocks can be placed in these two places, like 2 blocks of zeros over here and 2 blocks of zeros over here, or 3 blocks of zeros at this position and 1 block of zero at this position, or 1 block of zero at this position and 3 blocks of zeros at this position. So it is a simple rule that you cannot place two double columns in an IPv6 address. So what is the best you can do? The best what you can do is basically this. So you can place a double colon over here, but in place of these two zeros, consecutive blocks of zeros, you have to place two simple zeros over here. So this is the way to shorten the large IPv6 address if you have consecutive zeros in your IPv6 address. Now moving to the further slides. There are different types of IPv6 addresses available to us, and the first one I already told you, that the unicast addresses. The unicast addresses are those addresses which are destined for a particular host, and this unicasting was also present in the IPv4, and here it is also present in the IPv6. Then you have the global unicast addresses. The global unicast addresses are similar as that of public IP addresses. The private and the public IP addresses concept should be clear to you. In case of IPv4, the public IP addresses are those addresses which can be routable and which are routable, but the private IP addresses are those addresses which are non-routable. So in IPv4, you have 10.x.x.x as a class A private IP address, then 172.16.x.x till 172.31.x.x as the class B private IP addressing scheme, and then the for class C we have the 192.168.x.x. These are private IP addresses that you can use only in your LAN, and when you go to your WAN or to the internet world or to the shared media, then you require the public IP addresses. So you use the NAT router, that is the network address translation router in case of IPv4, which translates a given public private IP address from inside of the LAN to a public IP address so that it can move into the internet world. Otherwise, the private IP addresses are not forwarded by the internet shared routers. One more thing I want to clarify here is that IPv4 and IPv6 can coexist, and there are three different methods for the coexistence of IPv4 and IPv6 protocol, and these three methods are basically the dual stacking. In dual stacking, we have a router which has the facility for both IPv4 and IPv6. This is called dual stacked router or simply dual stacking. Uh, then we have the concept of 6 to 4 tunneling. In the 6 to 4 tunneling, we have the uh, we have a tunnel. At one end of the tunnel there is the IPv4 network, and at the other end of the tunnel there is also IPv4 network, but between these two tunnels we have the IPv6 network working. So this is called the 6 to 4 tunnel. And finally, the third and the last method for the coexistence of IPv4 and IPv6 protocol is the NetPT. NetPT is basically the translation of IPv4 address into IPv6 address using some router. So I was telling you about the public IP addresses. So these global unicast addresses are basically the same as that of public IP addresses in case of IPv4. So these global unicast addresses have the identification that they begin with 2000. So 2000, and then anything can come after in the other blocks. So these will start with the number 2000. So this is the global unicast address. So now moving to further topics of our IPv6 addressing. Now we are moving to the address types of the breakup of the addresses of IPv6 unicast global addresses. Basically, the unicast global addresses or the public IP addresses are divided in different fields. And as I have told you that the starting 64 bits, the starting 64 bits are the network portion. So in this network portion, these 16 bits, that is 48 till 64, these are the subnet mask bits. This is your subnet mask, and this is your interface ID. So what was mean by the interface ID? Interface ID is basically the host portion of an IP address. Now the starting 48 bits, these are like the 23 bits are for the registry purpose, and the 23 till 32 are the ISP prefix. That is whatever the internet service provider is using the field to identify itself. Now the company, obviously the ISP will be lending this public IP address to this company, and this company will introduce its own field from the between the portion 32 till 48. So then the company will decide the subnet mask from 48 to 64, and then the company will be assigning the IP addresses to its host in the interface ID portion. So this is the way how the IPv6 public address or the global unicast address is divided. Now moving to the link local addresses. What is mean by the link local address? As I told you in my earlier part of this lecture, the APIPA concept, automatic private IP address, or the automatic private IP address, APIPA concept, is basically a concept used in IPv4, and this concept is that if a PC or a host is not provided some IP address statically, and and you don't we don't have the DSCP server present in our network, so then the PC itself assigns some IP address in the range of 169.254. So that IP address is basically the APIPA. So if you have configured your PC to get IP address from a DSCP server, but the DSCP server is not present, or the IP address is not given to your PC by the DSCP server, then the PC will itself assign an IP address of the range 169 dot. So this is the APIPA concept, and these APIPA addresses are just used by the PCs to make itself someone. So here these APIPA addresses are called the link local addresses. So the link local addresses function as the same as that of APIPA, and they start with the range FE80. So that we can also check what is APIPA, and we can use the packet tracer to check that how a PC assigned itself an IP address from the APIPA range. That is very simple concept. Basically, what you have to do is to uh, have a PC attached to your DSCP server. So I am just opening my packet tracer. So now I am using my end device. As an end device, I am using this PC, and this PC, I am attaching this PC to a switch, and this 2960 switch is used by me, and then I am attaching with this switch my PC at the fast Ethernet port. The link is basically down, and now I am assigning my PC, asking my PC to get IP address from a DSCP server, but the DSCP server is not present. So we will check whether our PC assigns itself a PIPA IP address or not. So I'm clicking on the DSCP portion. It is requesting the DSCP address, IP address from the DSCP server. And here you can see that it is written that DSCP failed, APIPA is being used. And this is the IP address of the APIPA range, 169.254.61.98. So whenever the DSCP request fails, then the PC assigns itself an IP address from the APIPA range. So that I was talking about. And these APIPA IP addresses are basically called the link local addresses in case of IPv6. So now moving to the other part of our other slide, unique local addresses. So what is mean by the unique local addresses? The unique local addresses are basically the private IP addresses, but these private IP addresses are unique over the internet. That is basically this these unique local addresses will be non-routable, but they will be globally unique. That is, if you get a unique local address, then that address will not allow you to move on to the internet, but that unique local address will not be given to any other host in the whole world. So these unique local addresses start with the range FC00. So that was the unique local address concept. Now moving to uh, next slide, multicasting. As I have told you that multicasting is a feature that is already present in case of IPv4, and multicast is the way to get messages related to a group of users. So whenever a multicast message, for example, in case of OSPF protocol, the OSPF protocol sends routing update to only a particular set of routers, neighboring routers. So that particular set of neighboring routers is called the multicast group. So the multicast addresses start from the range FF00. In case of IPv4 addressing, the class D is used for the multicasting purpose. So the class D range started from the 224 dot till 239 in case of IPv4. But here we have the starting of this multicast addresses as the FF00 in the first block. So the other type of IPv6 address is the anycast address. So I told you the anycasting is basically you want to deliver your message to a particular host, but there are different nodes available or devices available or multiple interfaces available. So giving this message to any of those multiple interfaces or multiple devices will move your message to your required destination. Just like the courier service that I told you earlier, that if you give your parcel to any of the office of courier service, your parcel will get delivered to its destination. So that is the any casting. Now moving to the next slide. So this is a chart related to the IPv6 addresses. In this chart, there are some important addresses that you have to learn by heart. For example, this one. These are the since we have 8 blocks of all completely equal to 0, so we can place simply a double colon in place of writing this whole IP address. We can simply have this double colon over here. So what is this double colon showing? This double colon is showing that we have only zeros in our IPv6 address. So that is equivalent to 0.0.0.0 in IPv4. And what is mean by 0.0.0.0 is basically that the source address of a host before the host receives an IP address. So that is the any host address. So 0.0.0 means any PC. So simply 8 zeros in the IPv6 address or simply a double colon means the same. Now what is meant by this IPv6 address? This is the equivalent to the loopback address of 127.0.0.1 in IPv4. So what is the loopback address or 127.0.0.1 address? So that I will be telling you by using the CMD. Uh, Moving into the command mode DOS and pinging myself using the 127.0.1. This is called the loopback address. When is a loopback address used? The loopback address is used to check the TCP/IP protocol stack properly working on your PC or not. So if you are not getting internet services, you should check your own IP protocol, TCP/IP protocol stack, and that can be tested using this loopback address. So I am pinging it, and here you can see that I am receiving the TTL. So the pings are echoed back to me. So this is called the loopback address, and it is used for TCP/IP protocol stack working properly on your PC or not. So the same is for the IPv6 address, but here its format is all zeros, and the last one block is turned to 1. Now moving to the conversion of an IPv4 address into an IPv6 address. The IPv4 address can be converted into an IPv6 address by using this format. Here you can see that the last portion, that is 192.168.100.1, this is the IPv4 portion of your address. And then we have attached 6 more blocks. Why so? These 6 blocks, each block is of 16 bits. So 16 6 are 96, 96 plus 32 bits of this IPv6 address, IPv4 address, So 96 plus 36 is total 128. So you can use uh, this format to convert your IPv4 address into IPv6 address, and this is done in a mixed environment. Mixed environment means when you have both IPv4 and IPv6 working in your network. So I hope that these special types of IPv6 addresses are now clear to you. These were discussed by us earlier, and some are very simple, so you can have a look on these special type of IPv6 addresses by yourself also. Now moving to the EUI64 format. What is mean by EUI64? EUI stands for Extended Unique Identifier. So EUI64 format is a way that I told you in my earlier lecture that in IPv6 you can use your MAC address to get your IPv6 address developed. So how it is done? That is done by the help of EUI64 format. So EUI64 format helps you to create your own IPv6 address using your MAC address. So how it is now performed? As I told you that IPv6 address is of 128 bits, and out of those 128 bits we have the 64 bits for the network portion and the other 64 bits for the host portion. But here it is not called network and host, rather these are called global prefix and interface ID. So the 64 bit portion, that is the global prefix, that you cannot develop by yourself, that you have to ask from your router that what is the global prefix. So router will tell you about the global prefix, but the remaining 64 bit portion, that is the interface ID portion, that is the host portion, that one can develop by using the EUI64 format. That's why it is called EUI64 format, not EUI128 format, because the starting 64 bits, that is the global prefix, will be obtained by the router, obtained from the router or from the network or from the DSCP server itself. But the remaining 64 bits, that is the interface ID, that will be created by the host itself. So how does a host create the remaining 64 bits by its own self? That is very simple. You know that the MAC address is of 48 bits long. So a MAC address, if it is of 48 bits long, then what you have to do is to make its two parts. So the two parts will be of 24 bits and the 24 bits. And in place of, in the middle of these two parts of the MAC address, you have to place a triple FE. That is the triple FE. So if we add these 16 bits more, then of triple FE more, then 24 plus 24 is 48, and 48 plus 16 is 64. So this is the way to create or convert your MAC address into the IPv6 address. That is, divide your MAC address into two portions, separate the 24 bits and separate the other 24 bits, and in the middle you have to put the triple FE, so that your total bits become equal to 48. But one more thing has to be done by you, that the starting seventh bit, the starting 7th bit has to be toggled by you, because the starting 7 bit is the universal local bit, so that has to be inverted to 1. Okay, so that has to be performed. So now we will be discussing an example related to this EUI64 format. Here you can see that I have a MAC address, and this MAC address is 0C0C DD DED and then 1234. So what I have to do is to bifurcate this MAC address. Two parts will be obtained by me, that is 0C 0C and then DE. Now I have to introduce the triple FE in between these two parts. So this is the triple FE, and then DE 1, 2, 3, 4. So this is the way to convert your MAC address into the 64-bit form. But one more thing, that is the starting 7th bit will be inverted to 1. So here we have 0 and C. So converting this into binary form, 0, 0, 0 and 0. These are 4 bits. Then C means 12. So what is a 12? 12 is 1100. Now you have to toggle the 7th bit. First bit, second bit, third bit, fourth bit, fifth, sixth, and this is the 7th bit. So this 7th bit will be turned to a 1. So now what will be the overall value of this octet, this block now 8, 4, and then a 2. So now this is not 12, this is now 14, and 14 corresponds to E. So now the MAC address will be 0. So now the 64 bits of the interface ID portion will be 0E0C DE triple FE DE1234. That you can see from this answer. The starting 64 bits is the global prefix that you cannot develop by the help of UI64 format. This global prefix of 2001 0DB801 will be obtained by you from your router or some DSCP server, but this is your 64-bit other portion that is developed by you using your MAC address. So this is the way how to create or how to form your own IPv4 IPv6 address using the MAC address of your station. This is another example related to the EY64 format that you can check by yourself also. Here also the triple FE is introduced in between the 24 bits part of your MAC address, and also the 7th bit is toggled to convert the universal local bit, invert the universal local bit. Now the IP address allocation will be discussed by us. So the IP address allocation is done by three different methods in IPv6. The first method for allocating an IP address to a particular PC is the manual address assignment, or not only PC, but you can also assign to any router interface also. So the first method is the manual address assignment. In the manual address assignment, you basically type the command or you just statically configure the IPv6 address. The second one is the UI64 format that I told you, that how to create your own IPv6 address using the MAC address of your system. And the third one is the DSCP-V6, that is using a DSCP server to configure your PC with the IPv6 address by asking the DSCP server to assign some particular IP address to your PC. So that is done by the DSCP-V6 server. So in our second part of IPv6 tutorial, we will be starting our lecture from this point, how to manually assign a particular address to a PC or a router, and then the stateless auto configuration, that is the UI64 format. I have told you the theory of how to create an IPv6 address using our own MAC address, and then we will be dealing with the DSCP version 6, that is how to ask the DSCP server to get yourself a particular to get yourself some IPv6 address. So inshallah ta'ala, that we will be dealing in our part number 2. So kindly subscribe and like and share this video, and circulate this information of CCNA certification free online course among your friends too. Till then, it is time to say goodbye. Assalamu alaikum wa rahmatullahi wa barakatuh.